Hey kids, Mr. Murray here, Mr. Murray's Mathland, doing some more solving of trig equations today. And again, maybe you are great, you know the unit circle or your triangles, you have it all mentally organized. If you're a person who needs to whip out a little piece of scrap paper and jot it down as you would on a quiz, this is a time to practice that. Don't just look to a pre-drawn chart or circle in your notes. Think about what you would do on the quiz. And so here's a little practice for what I recommend if you have trouble keeping it straight. Sine, cosine, tangent in that order, if you set it up this way. Ascending order for the angles 30, 45, 60. And in radians, since we're answering with both pi over 6, pi over 4, and pi over 3, those values are all, sine and cosine are all over 2, over 2, over 2, over 2, over 2, over 2. The numerators are root 1, 2, 3 in order. Root 1, root 2, root 3. Count it backwards for the cosine. Root 1, root 2, root 3. And tangent is sine divided by cosine, right? Or y divided by x. And so since they have the same denominators, you're really just focusing on 1 divided by root 3, which rationalizes to give you root 3 over 3. 45 root 2 divided by root 2 is 1. And for 60, root 3 divided by 1 is root 3. So there are our values pretty quickly. I'm going to probably be using this for all problems. So I'm just going to copy this for future problems here on this video. And now number 1 here. So another video we focused a lot on factoring out a greatest common factor or factoring trinomials. But this is going to focus on a very specific technique that it's cosine and it's got an exponent, so it's cosine squared, but there's no other trig function in here. There's no sine or cotangent or anything like that. So if you've only got one trig function and it's squared, then I would isolate that and then use square roots. That's probably the way I would do this. So I'm going to subtract 7, right? I'm going to get this cosine completely isolated. 10 minus 7 is 3. Divide that by 12. Right? Completely isolate that, just like if you were solving an x squared equation. It's just cosine squared in this case. So that's 3/12, which reduces to 1/4. And now to take care of that squared, I'm going to take the square root of both sides. Just remember, if you take the square root of both sides to help you solve an equation, you need to remember plus or minus the square root of 1/4. And that's especially important in trig, right? Because you know that positive and negative dictate what quadrants your answers might be in. And so now let's just take a little simplification step here, plus or minus, and the square root of 1/4. It's a nice perfect square. Square root of 1 is 1, square root of 4 is 2. So no radical left over, and we're saying where does cosine equal to plus or minus 1/2? So when is cosine 1/2? Either you know it or you refer to it with a chart or the unit circle, but cosine is 1/2 at a reference angle of pi over 3 or 60. And where is it positive? Where is it negative? Well, the good thing about these plus or minus ones is, we have that all students take calculus to help us remember which quadrants are positive and which ones are negative. But cosine is positive in quadrant 1 and quadrant 4, and it's negative in quadrant 2 and quadrant 3. So when you have plus or minus, you're really just doing all 4 quadrants, so you don't really have to worry too much about it. So our final solutions are all the angles that have a reference angle of pi over 3, right? So that would be pi over 3 in quadrant 1, 2 pi over 3 in quadrant 2, right? 1 less than the denominator, 4 pi over 3 in quadrant 3, 1 bigger than the denominator, and 5 pi over 3 in quadrant 4, double the denominator minus 1. Or maybe you'd like to think in degrees first, and then you work to your radians from there, but that would be 60 degrees in quadrant 1, 120 in quadrant 2, 240 in quadrant 3, and 300 in quadrant 4, right? That's 180 minus 60, 180 plus 60, and 360 minus 60, right? So there are our 4 solutions in radians and degrees. and using square root to help us solve. So got a couple more examples, but of a very similar theme. So that's kind of the focal point of today's video, is focusing on using square roots. So I'm just going to see a few more examples. Feel free to hit pause and try to solve the problem and then check with my solution if you like. So here's another one. You've got tangent squared is the only trig function in here. So I'm going to get all my tangent squareds together and isolate it. So I'm going to bring 3 tangent squared over to the left side here. And while I'm at it, I'm going to add 5 to move those constants to the other side. So here is what I have after that maneuver. 2 tangent squared of theta is equal to 1 plus 5 is 6. And now I'm going to isolate that tan squared by dividing by 2. And I'll have tan squared is equal to 3. Hey, now I'm right there. I'm just going to take the square root. Just don't forget that plus or minus. If tangent squared is is 3, then tangent will be plus or minus the square root of 3, which doesn't reduce. And that's okay, because tangent being root 3 is a very familiar value to us, right? Tangent is root 3 at same reference angle as the last problem, pi over 3, or 60 degrees. And with that plus or minus, we're again talking all 4 quadrants, the 2 where it's positive, the 2 where it's negative. So I'm just going for it, right? That would be pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Same solutions as number 1, actually. That was just a coincidence, of course, but with the unit circle, there's only so many angles you're going to get, right? 120, 240 degrees, and 300 degrees. Okay. Big lesson, isolate that trig function, take the square root. Don't forget that plus or minus, because if you forget the minus part, you'll be only giving me 2 of the solutions, and you'll be losing half of them, and that's bad. Okay, last one here. I'll bring that chart back. Just figured I'd do one with a reciprocal function, like a secant, cosecant, cotangent. In this case, cosecant squared. So I'm going to add 7 and divide by 5. If you can do it all in one step in your head, go for it. Just don't make any silly mistakes. Silly algebra mistakes are the killers here. I'm going to divide by 5 now. Cosecant squared of x is equal to 2. And now I'm going to take the square root of that. Cosecant of x is equal to, again, plus or minus the square root of 2. And that does not reduce. So cosecant being root 2. That, you probably should recognize that. But if you're used to seeing everything in terms of the 3 basic functions, then, it doesn't hurt to take a step and rewrite that. That's like saying the sine of x, sine is the reciprocal of cosecant, is equal to plus or minus, and what's the reciprocal of root 2? I mean, if you haven't done this enough by now, 1 over root 2, which becomes root 2 over root 2 over 2. So I mean, yeah, when you get these ones with root 2, it's, pretty much a 45-degree angle. And that's the only time you see root 2's in these unit circle values. So sine being plus or minus root 2 over 2, that's 45, or pi over 4. And again, the plus or minus means all 4 quadrants. So x is going to be quadrant 1, which is pi over 4. Quadrant 2, 3 pi over 4, right? 1 less than the denominator. 5 pi over 4 in quadrant 3, 1 more than the denominator. And 7 pi over 4 in quadrant 4, double the denominator minus 1 for the quick patterns. And these are the 2 where sine is positive, if you like a little practice, quadrant 1 and 2. These are the 2 where sine is negative, quadrant 3 and quadrant 4. We want them all in this case. And in degrees, that's 45 degrees, 135 degrees, right? 180 minus 45, 180 plus 45 in quadrant 3, 225, and 360 minus 45, 315 degrees. So there we go. There are 4 solutions in radians and degrees. So today's video was just about that. Isolate and take the square root when you have just that one single trig function squared. Don't forget that plus or minus though. And as always, you got any questions, let me know. Keep working hard.